Before we write complicated C++ programs, we need to understand one of the foundations of programming: data types. A data type tells C++ what kind of data a variable stores, how that data is interpreted, and generally how much memory it needs. For example, int age equals 20. Int is the data type, age is the variable name, equals is the assignment operator, 20 is the value, and semicolon ends the statement. Let's start with int. Int means integer, which is a whole number without decimals. Examples are int age equals 20, int marks equals 85, int temperature equals -5. An int is commonly 4 bytes or 32 bits, and a typical signed int ranges from -2,147,483,648 to 2,147,483,647. Short is another integer type. It is commonly 2 bytes or 16 bits, with a typical signed range from -32,768 to 32,767. Long is also an integer type, but its size depends on the system. It is commonly 4 bytes on Windows and 8 bytes on many 64-bit Linux systems. Long is commonly 8 bytes or 64 bits, and typically ranges from -9,223,372,036,854,775,808 to 9,223,372,775,807. Now, unsigned integers. A normal int can store negative and positive values. An unsigned int cannot store negative values. A typical unsigned int is 4 bytes and ranges from 0 to 4,294,967,295. Use unsigned when the data genuinely cannot be negative, not simply because it provides a larger positive range. Now we have floating point types, float and double. Float stores decimal values. For example, float height equals 5.8. A float is commonly 4 bytes or 32 bits and provides around 6 to 7 decimal digits of precision. Double is also used for decimals. Double pi equals 3.141592653589793. A double is commonly 8 bytes or 64 bits and provides around 15 to 16 decimal digits of precision. In general, double is the better default when you need ordinary decimal calculations and do not specifically need float. Remember, floating point numbers are approximations. Values such as 0.1 cannot always be represented exactly in binary. Now, char. Char stores a single character. For example, char grade equals A. A char is commonly 1 byte. Notice that A uses single quotation marks. Also remember, 7 is a character, while 7 is an integer. They are different types. Bool means Boolean. A bool represents one of 2 logical states, true or false. For example, coolant passed equals true. A bool is commonly 1 byte, although its exact size is implementation dependent. Bool is extremely important for decisions such as checking whether someone passed, whether a user is logged in, or whether a condition is true. C++ also has character types for Unicode. wchar_t is a wide character type. Its size depends on the system. It is commonly 2 bytes on Windows and 4 bytes on Linux. char16_t is exactly 2 bytes and is designed for UTF-16 code units. char32_t is exactly 4 bytes and is designed for UTF-32 code units. Void is different. Void means there is no value. You commonly see it with functions that perform an action but return nothing. Now, one very important point. These sizes are not all universal. C++ is designed to run on many systems. The standard defines minimum requirements and relationships, but some exact sizes depend on the implementation. For example, int is commonly 4 bytes, while long can be 4 or 8 bytes depending on the system. So don't guess. Ask C++ using sizeof. For example, cout less than size of open parenthesis int close parenthesis less than endl semicolon. You can also use sizeof with float, double, char, bool, long, and long. On many modern systems, you will commonly see int 4 bytes, float 4, double 8, char 1, and bool 1. Finally, type conversion. If we write int age equals 20, double value equals age, C++ converts 20 into 20.0. But converting the other way can lose information. If double price equals 99.99 is stored in an int, the fractional part is discarded, giving 99. We can make the conversion explicit. Int amount equals static underscore cast, open parenthesis price, close parenthesis semicolon. So remember, int, whole numbers, commonly 4 bytes. Short, smaller integers, commonly 2 bytes. Long, integers, commonly 4 or 8 bytes depending on the system. Long, very large integers, commonly 8 bytes. Unsigned, non-negative integer values. Float, decimals, commonly 4 bytes, about 6 to 7 digits of precision. Double, more precise decimals, commonly 8 bytes, about 15 to 16 digits of precision. Char, 1 character, commonly 1 byte. Bool, true or false, commonly 1 byte. Whether underscore t, wide character, system-dependent size. Char 16 underscore t, 2 bytes. Char 32 underscore t, 4 bytes. Void, no value. Data types are not just things to memorize. They tell C++ what our data means, what values it can represent, what operations make sense, and how that data is stored. And that is why data types are one of the foundations of C++.
Thanks for watching. You can watch our latest uploads. Want more of us? Don't forget to like and subscribe.